Hi everyone, I am Yamini, Department of Computer Science and Engineering, SNS College of Technology. Today we are going to discuss about singly linked lists, one of the most widely used dynamic linear data structures. We will understand why singly linked lists are needed, how they are organized in memory, and the basic concepts that make them different. Let us recall a array-based list. Before discuss a singly linked list, let us quickly review an array. An array stores the element in continuous memory location and every element is assigned using its index. This allows a very fast random access. For example, if an array contains the value 10, 20, 30, 40 and 50, we can directly access any element using a position, although array are different for accessing data. They have limitation when data need to be instead of a singly linked list. Next one, that is transition. Introduction to linked list. Now let's thanks about application where data change continuously. Imagine manage browser tabs, a playlist or task in a scheduler. These applications required frequently addition and deletion, make array less suitable. This leads us to concepts of singly linked list. Next, understanding the user needs. Programmers need a data structures that can grow or sync dynamically without wasting memory. It should allow a fast insertion and deletion of elements without shifting existing data. It should allow avoid the requirement for storing the data in continuous memory location. In real world application such as music playlist, browser history, memory allocation, and task management all benefit from this flexibility. Next one, defining the problem. Array have three major limitations. First, there are size is fixed. Second, insertion and deletions are expensive because elements need to be shifted. Third, they require continuous memory allocation. Next one, that is, and therefore the challenges is to design a data structure that overcome this limitation while still storing data efficiently. Next, brainstorming the solution. Several data structures can be considered, including arrays, stacks, queues, doubly linked lists, and circular linked lists. However, the simplest and most effective solutions of dynamic storage in a singly linked list. In these structures, every node contains two parts, the actual data and reference or pointer to the next node. This design allows a memory to be allocated only when needed. Second one, singly linked list structures and working. Let us understand how singly linked list it works. A singly linked list is made up of individual nodes. Each node stores two pieces of information, the data field which contains the actual value and the next pointer which stores the address of the next node in a sequence. The first node is called a head node because it marks the starting point of the list. To access all the elements, we begin at the head and follow each next pointer one by one. Unlike arrays, the node is a linked list or not stored in continuous memory location. They can exist anywhere in memory and the pointers create the logical connection between them. Final node container null pointer indicates that there are no more nodes after it. This marks the end of the linked list. One important advantage of this structure is that inserting or deleting a node usually requires only change a few pointers instead of moving all the elements, making these operations much more efficient than in array. However, since linked lists do not support a indexing, searching of an element required visiting each node one by one from the beginning. This is why singly linked lists are ideal of application where inserting and deletion happens frequently, while array remain better for fast random access. Thank you.